Welcome to Talks. This is a forum we have every Tuesday that passes in session. It's kind of a place for people to get together at CMU Silicon Valley. We have a little bit of a cookies afterwards for hanging out and meet faculty and students and the new speakers that we have in general, we've put together about 150 of these talks. People from every possible exciting place, from Harvard, Stanford, Berkeley, Yahoo, Google have spoken here. And we'll go till about 2:25, and then we'll go out into the hall and talk out there. I encourage you all to ask questions. I think the talk gets more interesting when you do. We have a tendency to use the flying mic to toss the conversation around. I just talk into this thing. You don't have to have it too close to your mouth, but the red top is what you talk into. Here, I'll just pass it to you, and you can say hi. Hi. So that's how it works. And just whenever you have a question, I'll send you the flying mic. Also, this is online, and there might be people that come in, and if they ask a question, I might pop up my hand and try to get that answered as well. Today we have a very exciting man, Allan Alcorn, who's done just so many things. He's an engineer from probably birth or something, or from prenatal engineer. And one of the thing that we know him for is starting Atari, the game company, and doing it by being the guy in the seat building the frickin' before computers Pong game out of actual chips and making that work. He's made lots of other things work. He's got the major patents on how the modern machines in Las Vegas do their thing too. But anyway, so he's here to speak with us, and without further ado, hello.
Thank you very much, Ted. Pleasure to be here. I've been very fortunate in my career. I've been very lucky to be at the right place at the right time. Try that one, try that one, try there. That one works. Okay, so I should say I grew up in San Francisco. I'm actually a fifth-generation Californian. Our family pioneered Boulder Creek in the Santa Cruz Mountains back then, owned the town of Boulder Creek. But I went to Cal in the 60s, which is a very interesting time to be at Cal, reading, writing revolution. I got into the work-study program at Ampex. Work-study was a very good, I thought I would work, the idea was you work 6 months in industry, then go to school for 6 months. And I figured I'd make enough money doing that, I could pay my way through school. Well, I drank and pissed it away as fast as I made it, but I learned a lot about engineering. It was really handy because when I went back to school, I knew what I wanted to take with a vengeance. I knew why I wanted to take it. And I was always interested in analog and video. I thought digital at the time was just so many ones and zeros, and it wasn't very interesting. Fortunately, Berkeley wouldn't accept that, and they made me take some computer science courses, which did come in very handy. And I wound up understanding the analog problem really well of video, both in my career as a TV repairman from when I was in junior high school. My neighbor across the street had a TV repair shop, so I was fixing TVs. By the time I was in college, I was a journeyman repairman. I actually worked my way through Cal fixing TVs just off of campus. So I really knew how TVs work, which was really handy later on. So the first video games, the first video games were, a commercial game was Pong in '71, Magnavox Odyssey. Before that, to be very exact, there was Higginbottom had a CRT oscilloscope demo, so there were games made out of digital and analog circuits. Magnavox Odyssey was all analog, and that was the first device that actually hooked to a TV set that played a game. And that was back in '71. Didn't sell very well, but video games became a big business pretty quickly. Let me see here. So the revenue of video games went from about $1 billion in 1980, or zero in 1972, to now around 78 billion currently. So here's the earliest video game. It was at Brookhaven in 1958, and it was a kind of a tennis game that that you just basically bounce the ball over the net with some potentiometers, and it was used as a open house demo so kids could know what their parents did for a living. Then, of course, there's the Space War game, and I hope you can see that. They actually have a PDP-1 at the Computer History Museum, and it actually is playing Space War, and I think it's just fabulous. And that actually is how the first video games came about. There's the Magnavox Odyssey game. It was a very crude game, but because it was analog, it didn't play very well. It was all exponential decays to the ball, and it just wasn't fun to play. But it was the first thing hooked to a TV set besides an antenna. So Nolan saw the Space War at the University of Utah, and he also worked in an amusement park in Salt Lake City. And that was very important because Nolan worked as a in the slot machine, in the arcade, in the pinball machines that they had back then. And so he's understood the business. He understood the business of coin-operated entertainment. And University of Utah was one of the few schools in the country that had a PDP-1, and Ivan Sutherland was there. And so they had graphics, and you could say computer graphics were almost invented there. And Nolan would come in midnight with his buddy and play the game, and said, you know, if we can put a coin slot on this thing. And that was in the back of his head for a long time. So he joined Ampex in 1968, about the same time I did as a student. He had graduated, but he wasn't much as good an engineer, but he was a good entrepreneur, and he really wanted to push things. So he went ahead, and him and his buddy Ted Dabney, his partner, figured out how. Well, their original plan was to buy a Supernova, which was like $2,000 back then, a lot of money. So now I have a computer, and I could maybe run 5 or 6 video games off of this one computer. It just didn't work out. Those machines were way too slow. And kind of musing the problem, as he tried to build an interface for it, there was less and less computer involved. And all of a sudden, he came up with a hook, how to make this thing work. There's the computer space. Now, his first machine was computer space. He left Ampex, quit a good job in 1971, and found Nutting Associates was the first, or the only, coin-operated manufacturing company west of Chicago. And he found it through his dentist. What a coincidence. He happened to be living in the same town. The only other company could possibly do this. So he quit Ampex and brought his idea to these guys, and he wanted a fiberglass cabinet because it looked space age. That was a problem. But what it really was a raster scan implementation of Space War. It was the same kind of game. You're flying a flying saucer, shooting rocket ships. If you're ever fortunate enough to see a computer space running, play it. It's actually a vacuum tube, black and white TV in there. So the fact that it runs at all is amazing to this day, 50 years later, 40 years later. Yeah. So then he split with Nutting. Nutting decided that Nolan was just, this was back in 1971, 72. And you have to consider that people didn't do startups. Today, it's very fashionable to be an entrepreneur. That wasn't a word that was thrown about. And you had a good job at Ampex or Lockheed, you stayed there. That was a career. And they quit and did this. We thought they were crazy. Well, I happened to be back at Ampex in 72, and Nolan and Ted show up, and they offer me a job. And they offered me $1,000 a month salary, which was a little less than I was making at Ampex, and 10% of the stock. Stock meant nothing to me, $1,000. I didn't need the money. It'd be fun to work in the startup company, and then it would fail, and I'd go back to work at Ampex. That was my plan. So Nolan gives me this task to do the very, very simple video game to break me in. He didn't tell me, but he had seen the Magnavox Odyssey game, simple game. So he defined the simplest possible game he could think of to get me as an exercise to just designing games. I'd never done a game before. The only person who ever had was really Nolan. And he explained this trick. with the raster scan. There's the team. Well, okay. Yeah, that's me with hair. That's Ted Dabney. That's the Pong machine, and that's Nolan. This guy we don't talk about much. That's Fred Marinchak. He didn't work out. Let's just say he didn't work out. But he was there early on, and it was crazy. It was really, we had no idea what we were doing. We got into production, and this thing just hit off. I mean, the famous story, I'll repeat it, is where we had it at 80 Caps Tavern up on El Camino Real and Matilda. It's now Rooster T. Feathers, and it was a good location for us. We had a lot of pinball machines we used for cash flow, and the machine stopped working pretty quickly. You can see that prototype. It's a bar top thing, a tabletop thing. You can see it at the Computer History Museum. If you look in the back, you'll see it's a very, very, very poor wire wrap. It barely worked. It was just thrown together to see if I could do it, not to put on location. So the fact that it broke didn't bother me. I went over there, opened up the coin box, and the money just flew out. And I figured, gee whiz, that's a great deal. There's the original machine. It's at the Computer History Museum. 2 controls. Pong, no instructions whatsoever. The only game I know that requires 2 people to play. There's no one-player mode. You'll notice there's a stock TV set. Speaking of kind of technology, at the time, you could buy a monitor from Motorola. It cost about $300. They were green. They used them in airports, and they were always broken. And I said, screw that. I'm going to go buy a Hitachi TV set at Walgreens, and I, being a TV repairman, I could turn it into a monitor pretty quickly and use the sound that was in there. So I turned the antenna to ground, sound, and video. There's a wire wrap board, power supply, very, very crude. That was the original Pong. And there's a machine. So for those of you to understand a little bit of how video works, consider it's analog, and you're having a raster scan. I assume you know about that, scanning horizontally and then vertically, 15,000 hertz horizontal scan rate, about 63 microseconds. There's a sync pulse, every horizontal retrace, and then there's a color subcarrier, 3.58, and then there's the active video area with, there would be a paddle, black is down, white is up. And then, if you look at vertical, it's just a series of these in that. And the way you do it, the way I did it, because it's supposed to be all analog, simplified block diagram. So what you do is you have a crystal oscillator, divide by 455. If the crystal oscillator is about 7 megahertz, and that gives you your horizontal timing. So there's a counter. You have digital counts. And then a similar thing happens in vertical. So what if I have another sync generator with the same count, divide by 455, but adjustable to 455, 454, or 456? What happens when I turn them on, they'll be in sync, but they won't be lined up. They'll be going at the same rate, and you'll have a bar stationary if it's 455. If you move it over to 454, it'll move to the left and move to the right. So you don't know where it is. You just know it's somewhere, and you can detect when the ball hits the paddle. The paddle is generated. And that's how it worked. It's very simple. So there was no memory, there's no microprocessor, just counters. So it was all parts digital TTL chips that cost about 50 cents, 25 cents a piece. There were about 70 of them in there, and that was Pong. You'd think you'd use memory, but you have to remember, back in 1972, there was no memory, and there was no microprocessor, except, to be technical, the 4004 had just come out. But it was so slow, you could almost watch it work. It wasn't going to work at these rates. So business-wise, we got hit in the ass by lightning. We were just an amazing success, really fast, all of a sudden. It was really weird going from Berkeley in the 60s as a kind of an anarchist, shit disturber, to all of a sudden we're making $1 million a year, which just seemed crazy, but it was fun, and we were all young, and we just went see how far we could go before they'd blow it up, they'd take it away. So then at one point, Nolan decided he wanted on a chip, a custom chip. So, okay, I'd never done anything like that. This is before ASICs existed. Again, this is now 1973, 1974. And I hired a guy. I had a problem. The coin-op games we were doing just fine, except there was a whole industry of people stealing our stuff. And what I mean stealing, there wasn't stealing a program because there was no program. They literally get copies of the printed circuit board, put parts in them, and boom, they had the machines. And you can't sue them. They go out of business if you try to sue them. They come pop up somewhere else. So I was looking for a way to make a custom chip to make our games harder to copy. Just to have, I'd pay more to have a stupid function just to make it so idiot couldn't copy it. I hired an engineer, Harold Lee, about the same time I hired Steve Jobs. And Harold was a logic designer and a chip designer. And he knew he had a very broad experience. And he said, you know, Al, it's not going to work to make this chip to stop copying because your technology is changing too fast. But I think I can put the simplest game, Pong, on a chip, N-channel chip. I said, great, let's do it. I was so tired of managing. Now, what happens when you get a successful company, you're an engineer, great, success. You don't have to do engineering anymore. You're now managing people. You're now babysitting. That wasn't as much fun as engineering. So this was a great opportunity for me to give my job as coin-op VP to Steve Bristow, and I went off with two other guys, see how far we could do with the chip, see what would happen. And Harold did the logic. My wife would wire wrap it. I debugged the wire wrap, correct the schematic, give it back to him, and eventually we had a working wire wrap that represented the chip, and we had a design we could put on the chip. We then went out to Kalma in the midnight rented time on a machine to lay the part out, and boom, it worked. I was stunned. Now this was a N channel, which is different than today. But I'll just say it was plus 12, minus 5, and 5 volts. Required 3 power supplies, which is kind of funny. Also, there was a real big problem with the FCC regulations, which we have today. But let me give you some background on it. There were really no regulation of this kind of device under Part 15 back in 1970. And when the Magnavox Odyssey game came out, the FCC said, okay, we got to control this because you're hooking something to the antenna of the TV. Remember, those were screw terminals. They aren't coax connectors. And people didn't hook anything to that TV antenna connection but an antenna. There was no cable TV. There were no VCRs. So people weren't used to doing it. And if you just hook this up and laid an antenna on it too, you'd be broadcasting this thing and creating all kinds of interference. So what they did was they set the rules, assuming it was an analog game, and which the original Odyssey was. And so by 10 or 20 megahertz, there was like 1 microvolt per meter allowed. It was unbelievable, way beyond what they needed for military spook work, Tempest. So it was extremely hard to do that, but it acted to keep out competition because it's one of these wonderful things when you have this stupid regulation that was too strict. Once you can accomplish it, that's a great regulation. They should build that wall higher, keep all the competition out. That became a big factor later on when we were doing the home computer. When Apple shows up with the Apple II, that thing radiated so bad, if you ever try to run an Apple II, an original one, that you couldn't watch a VHF television within 2 or 3 apartments of a guy running one of these things. So in fact, it was so bad, the modulator to run on a regular TV set was a UHF modulator. You had to get it way up in the UHF channels because the RFI coming from the actual machine itself was much stronger than a TV signal. Not easy to solve the problem, and it was really, really hard. But that was one of the things we had to do, and we sold about 1 million of them our first year. It was amazing, through Sears and Roebuck. That was the unit, and that, technically, that is actually the correct early version. People are confused about this, and I've seen it read many times wrong. It's Telegames, which is a brand, that proprietary brand for Sears, but it did say Pong and it did say Atari on it. Some people have said Sears copied it. No. Sears was really helpful. It was one of the things we would have destroyed ourselves if it hadn't been for Sears, because they did They did the testing for us. They helped us get it through the FCC. They had a big lab that nobody ever knew about. They also did all our marketing and paid their bills on time. Unlike the real consumer electronics, these guys, when you ship it for Christmas, if you expect to collect any money after January 1, you better have another product that they want, or they just won't pay you. And what they'll do, all the units they don't sell, even though there's no return allowance, they say, oh, they're all defective. They'll open the box and send it back to you, and you got to prove they're not defective. So it's a tough business. And Sears was so great. So then the problem about that time was every game was a dedicated chip. If we wanted to change the game, we had to make a new chip. And that was very, very hard. I will give you guys one little tip. One thing I learned, excuse me. They came to me shortly after Pong was out, and it worked on NTSC American television. And one of the marketing or sales guys said, Al, we need the PAL version, European TV. I said, well, if I do a PAL version, it's a different chip, and I can't do another chip for the domestic market, and we know that market, so I'm going to pass on it. And the guy said, well, you know, some Koreans took your chip, and they turned it into a PAL chip. So wait a second. They don't have access to the chip. Oh, no, it was outside. So I thought about how would these guys do that? They've got no standards, no taste, and it occurred to me, since the chip was N-channel, it was static logic, old-fashioned. So if you stopped the clock, the part would just sit there in the state it was in. And if you waited, one of the big differences between PAL and NTSC, if you think about color, was the frame rate was 50 hertz instead of 60 hertz. So you just fired a one shot at the bottom of the vertical sync and waited enough time, you could make it 50 hertz. You'd have bar at the bottom of the screen, there'd be no color, but you could make it work. I go, God, that's how they did it. Then I found out the sales guy was bullshit and lying. It wasn't true. But knowing that somebody else had done it caused me to think, well, how would he do it? Because I knew it couldn't be done, but once I knew it was done, oh, I see how he did it. So I encourage all of you to sometimes stop what you're doing and think back, how would my worst competitor knock me off, undercut me? Because there may be some big space below you, and they'll find out eventually. So we realized that we had to go with the microprocessor system, a cartridge-based system. So we could sell games in software and not have to make a new chip every time. At the time, I'll explain the technology at the time. First off, we had identified the 6502 microprocessor. That was a very fundamental, the history of that processor was, the first processor was out by Intel, the 4004, then the 8008. About that time, Motorola made something called the 6800. Was it 6800 or 68,000? 6800, 6802, yeah. And a guy working there, Chuck Peddle at Motorola, hey, I got some improvements. It was coming out. It was very simple, straightforward, 8-bit. But he said, I can do a page 0, make all the 0 order 256 address one cycle to get to. So it was like having 256 stacks or registers. Thank you. Exactly. And the other thing, he did pipelining. So it would go twice as fast. And he took it to Motorola. And at some point when you're running a company, you have to shoot the engineer and ship the product. You can always improve it. And that's what Motorola did. They said, forget it. We're not doing it. We're shipping it. So Chuck wouldn't take no for an answer. So he goes off and joins a company called MOS Technology. Not MOSTech in Texas, but MOS Technology in Valley Forge, Pennsylvania. And they say, sure. And they build a part called the 6500, which is, well, one version was pin compatible with the 6800. It would actually work. It just worked faster. And there was a lawsuit involved. Nevertheless, that was the 6502 back in the 70s became easily the highest volume microprocessor being sold, and no one knew about it. Intel was advertising, and Motorola was advertising, and there wasn't even a development system. There was one, but it was so bad nobody used it. But yet, that was the most. So for several years, we were the largest users of microprocessors, and Apple right behind us. Now, we also did something that's the VCS. We solved the FCC problem by inside of it's a zinc metal hot metal die casting like a carburetor. It's built, you could, sledgehammer would not get through that thing. So it just stopped all the RFI. So let me tell you one more thing. Yeah, so the cartridges were 2K bytes of ROM. They wanted to go to 4K when it came out, but we wouldn't let them because they'd cost more. And so we actually made a chess game that was a very good chess game. The VCS had 128 bytes of memory in it, RAM, and it had, like I say, 2K bits of ROM. And we built a chess game that was one of the better ones in 2K. Nobody bought it, but it was an enterprise we loved, and the other thing that was very interesting about the VCS architecture, if I can describe this, it was different. At the time, our main competition in this category, home games, was coming from all the semiconductor companies because they want to sell semiconductors. Places like Bally, Mattel, they want to sell video games and they don't want to wait around designing their own stuff. So Signetics and all the different companies had proposed video game designs that, guess what, all used memory maps, lots of memory, sprites, and they used about 10 or 12 chips. That machine had a 6502 microprocessor that cost about $2 or $3 at the time, a TIA chip, just an expansion chip, interface chip, and the ROM. That was it. So you opened it up, and all our competition had like a dozen chips, and they were expensive. We didn't have a frame buffer memory. There was very little memory in it. How did we do that? Well, we designed it so it wouldn't use a lot of silicon. So we made a little chip called Stella that would do two scan lines of video at a time. And the program ran fast enough in the CT502, you could keep up with it. You had to count clock cycles, so you finished drawing before the line ended, and then vertical sync was in software. So one way to tell, if you're running a game on a VCS and you pull the cartridge out, you'll see vertical bars because it just stopped where it was. So because we did that, our cost was way under everybody else. But you also got to realize there's a philosophy. When a semiconductor company, their goal is to sell silicon. Our goal was to make money by selling entertainment. So we rejected that architecture. And because, well, the other guys, they had chips that did sprites. They said, oh, well, an object is going to be 16 by 16 box, and you can do this and do that. What happened was they were defining what the game was going to be, where it was going to go, by making these strictures. You had to do it to make a decision. But because we didn't have any of that, because it was just completely bare, this machine became far more flexible than all the static machines that were out there until you got to something like an Apple II, which had enough compute power to actually do some decent games. So the first thing that I think the early games, the controllers, we had to invent our own controllers because Godzilla plays a coin-op machine. If that machine steals your quarter, you feel you have a right to destroy the machine. We understand that, so we got very good with the joysticks, you see. Back in those days, you could buy joysticks that people like NASA used, and they were very nice, but they were fragile. You could break them, and they cost hundreds of dollars. We had to build something. I remember we had a good designer up in Grass Valley, and there was a stainless steel shaft inside the joystick, so you could sit there and put a car on it. It wouldn't bend. When we did a trackball with a bowling ball. Cost us like $40 cost of goods. You buy one from the military suppliers. They're very expensive. And if you poured beer on it, we had a drain and a hose that would drain it on your foot, and the stiction would make the bearing work better. So it was that kind of clever stuff. The displays, I already told you about that we went to raster scan. Eventually, we just used a regular television. Eventually, Motorola got off their butt and designed a proper cost-effective display. Well, again, we were the biggest users of microprocessors in the world at that time. And I've explained the design of it. So later on, after Atari went away, I don't know if you hear about all that, but it was ugly, as companies go, and success. It's funny. I'll say this about companies. I call it success disaster. So Atari was a wonderful company to work for till about 1979 or 1980, and Warner bought the company. It was fun for a while, and then they didn't like us because they bought us because we were unique and crazy and built these unusual things, and then we kept doing that, and they didn't like that. We didn't fit the corporate culture. And they didn't understand. One of the things I think we here all understand is that if you don't obsolete your own product, somebody else will. Things don't just sit static in Silicon Valley. These guys were from back east. The president, Ray Kassar, was from Burlington Industries, fabric, bed sheets. Things didn't change, and never got the handle of that. And what happened, and I thought it was just Atari, but it's any company. I saw it at Apple. When you have a product that is so successful, the organization itself forms an immune system around that product to defend that product from attackers. And attackers are people like me and Ted that go in and say, hey, you can make it better, faster, cheaper, or do this or that. And you go, you're rocking the boat. This thing's making a lot of money. It got so bad at Atari, they were making $1 billion a year by 1981 on cartridge sales, 82, and nothing, no new products were released at all. Many were developed. Alan Kay worked there. We had a lot of interesting stuff going on. They had no courage because what happened if you released a product and it failed? Then you'd look stupid. Yeah.
Al,
Yeah.
was it that they were from the East Coast, or was it that they were from the entertainment industry?
I think it was that they just weren't from Silicon Valley. I'd like to blame it on everybody from the East Coast, but I don't think that's true. I just think they, even was in the entertainment business, they just weren't into Silicon Valley and understanding the rapid pace. Remember, this was 1978, 77, and life was so much different out here, and these guys were, I guess they're a little bit arrogant and wealthy and felt they knew everything. And I eventually got rid of me because I was running around saying the king has no clothes, this company's going to die, and they asked me to go away in 81. They paid me to go away. They hit 2 or 3 years, paid me not to show up. They weren't working anywhere else. So that was interesting work.
Al,
Yeah.
I happened to work with Allan Kay
Yeah.
there in 83, 84, and what was fascinating is that they had a habit of paying lots of people to go away. There was about 50 VPs, and they'd have a half-life of about 6 months, and then they'd be paid to go away, and they'd have to pay them for a few years. That's one of the ways they were spending a lot of money.
Yes. Yes. I even had a company car not to show up in. That was a good deal.
Exactly.
That was a good deal.
Ted Hoff's company car not to show up in was a Jaguar, a brand new Jaguar.
See, I had a BMW. I wasn't quite as well. Hey, what the hell? You know, so it was really funny because, I mean, part of the thing here, yeah, it's technology, but it's culture. And you can have all the best technology in the world. It doesn't buy anything if management doesn't get it. And what we're doing, what our job is to be disruptive. I'll say one thing, that Ralph Baer, the guy who did the Magnavox Odyssey game that was kind of a flop, and the poor guy never made much money out of it because he worked for Sanders Associate, never had any stock or equity. But he had the courage. He built that product in a hidden lab behind the wall. It was Sanders Associates, now Lockheed. That was not something they did. He did it in spite of management. The whole project was a G job, what they call, you know what a G job is? You guys are too young. G job is a government job, cost plus. So the more work you did, the more the company got paid. So it didn't really matter if you weren't doing the right thing. You were just doing something. So he went off and did this and had a team and built this whole product and somehow got them to sell it to Magnavox and had a patent that got them a lot of money. Didn't get him any money, but got them a lot of money. So, but that was amazing what he did, because that just doesn't happen. And that's the way it does happen in startup companies. Ampex would never have done a video game, nor would Bally, the dominant coin-op pinball machine guy. They were so busy making what they had. We were disruptive, so it can pay off to be disruptive. Eventually Atari went away, their own arrogance and their lack of taste. Ray Kassar never played a video game and didn't know what a good game was. And unfortunately, long story, different story, but they shipped some crap and it didn't sell, and that was the end of Atari. Big crash. Nintendo took over. I think Warner came to the conclusion that video game market was gone, like the hula hoop. But Nintendo knew better, and they basically knocked off the VCS and added cryptography to it. Kind of a poor version of cryptography, but it kept all the other guys from making cartridges. It was another thing. We were the only guys making cartridges for the VCS, we thought, and because of Ray Kassar's arrogance in treating the engineers like high-strung prima donnas, unquote, they all left. All the good ones, software programmers, left and formed their own company. Magic, Activision was formed, spun out of it, the best engineers. And we sued them and lost the suit. So it came wide open, and Nintendo came in. When they came in, they put cryptography in some so that you couldn't, a third party couldn't make cartridges that would run. It wasn't that great cryptography. In fact, the old Atari coin-op did make some cartridges. Nintendo was using this you had to make a cartridge for the Nintendo system, you had to give it to Nintendo and they would make the ROMs. So if they chose not to make the ROMs or they were too busy, you were out of business. So Atari, and they would just favor the Japanese companies and not the Americans, so Atari said, screw it. They just cracked the poor cryptography and did their own. Another lawsuit involved came out of that. So I think clearly video games had had an impact on computer graphics. In the first place, the high-res color on the Apple II was a product of Atari, and I'm really proud about that. Jobs and Woz, well, Jobs worked for me. Woz came with the package, it turned out. He working at HP, and when they were building the Apple II, developing it, I thought it was cute and interesting and fun, but I didn't think there was a market for it because there's no software. I mean, it was just a computer. And my wife couldn't use it for anything. We passed on it, but I remember Woz coming to me and asking about how color is made, how the NTSC color, and so I gave him a chalk talk for about a half hour. He is a savant, a genius. He sucked it up and merged the DRAM refresh into the color display, got it for free. Very clever design, genius. Then the Amiga came out, and the Amiga was the first computer with a GPU, graphic processing unit external, and that came out of Atari. That was Jay Miner and those guys that worked for us, and they built the successor, the machine that Apple should have built and didn't build. And that machine was unique for its ability to handle color video. So you could actually, it was very popular in making video editing and video graphics. A lot of special effects were done on Amigas in those days. Now you see the NVIDIA's and others graphic processor chips that are just amazing. Systolic arrays, and there's now OpenGL or whatever, not OpenGL, but there's a programming language you can program those things. These are machines of the order of the Cray in speed and power for dollars. It's just remarkable, and they would not have existed had it not been for video games. I think the Connect box, to me, is fascinating. It's probably my favorite piece of technology that Microsoft ever did. It was a long-standing problem how to look at people, and people who've been working on it in research for decades, but Microsoft, for whatever reason, worked on it and really finished the product, and it's just remarkable. I don't know if we'll ever see anything out of Microsoft again like that. There's about 20 million of those things out in the market today. It's remarkable. I think it should be used more. There's the Connect. So, I'll take some questions. I think that the mass appeal of video games certainly is a driving force. It's a huge industry. It's like, again, 70 some odd billion dollars today. It's bigger than movies and whatnot. So it can justify a lot of technology and a lot of silicon.
What an amazing story. It's really great. A lot of those pictures and even things you've said, I've known you for a long time, but I learned a lot during this talk. Yeah, who wants to ask questions?
Eugene, you got to have a question.
Yeah, but I can talk to you anytime.
Yeah.
Oh, what happened to nerds.com?
Oh, that. I never had it. I thought a friend of mine had it, and it turned out he didn't have it, and his brother was an idiot, had it. It's working again now, but it might try it again. It might be working now. Yeah.
I remember in the early to mid 80s there was something, it was a vector graphics game.
Yes.
Vectrex.
Well, that's a good answer. I forgot about that. We actually started it. We had a coin-op game, the Battle Zone game, which was a first-person tank game, and it was an XY display. I gotta say, Atari was wacky. I heard about this at a talk somewhere else somebody else gave, and I realized it, that every game we did in CoinOp was new, whole new game. We didn't do sequels to old games. Every game was new. Every game was new hardware. And so some guy said, well, let's do XY. So well, there's no XY displays. If you think raster scan displays, so we invented our own and had Electrohome build it for us. We used horizontal deflection amps, audio hi-fi output chips to drive the yoke. And so that was the XY game. And then there was a home version made with that. It didn't really take off too well, but in fact, the other place that technology showed up in was ETAC, the first car navigation company in 1983, had an in-car navigator that used cassette tapes. And they made a little version. We showed them, gave them the design of the thing, and they made a little XY display in the driver on a stock. So yeah, those are crazy. Yeah, yeah.
Questions? Well, I guess, one of the things that's interesting is how corporate cultures follow. When you're in one, it feels like it's the only way a company can be.
Yeah.
And when you're in another one, suddenly you realize that it isn't.
Yes.
I don't know. You've been in you were at Apple.
Yeah.
All these places. You built this corporate culture at Atari.
Yeah.
Do you have anything to say about that?
That was interesting. We didn't intend to do that, but we did, because I was 24, Nolan was like 25. We'd all worked at Ampex, where we'd experienced, you showed up at 8 o'clock in the morning, you left at 5 o'clock, literally. You took a 1-hour lunch, literally. And you didn't stay late or work after hours. And you wore a suit and tie or a coat, sometimes a lab coat. When we started Atari, Christ, we're just guys, we're all engineers, so we didn't put any rules in unless we had to. And we eventually put all the rules you have in, but we learned every one why you had to do them. But we had fun with what we were doing, and so we didn't try to manage based on time. We said, look, you're all adults, you want to get something done. If you don't show up, I don't care. Just get it done. If you get it done on time, fine, tell me how you did it. And this is how one day this breakout game, I go into the lab, there's this game Breakout, working. It isn't on the list of things to do, it's working. Well, it turned out Jobs and Woz did it in 3 days on their own. Nolan told them to do it. But yeah, that was a different kind of culture, and we started changing. I think we helped to change the culture to be more laid back, more open, more goal oriented. That was fun, but I think what was more important is we treated everybody. There was no politics at Atari. We were all young. We all respected each other. We felt safe. That I realized was unusual. That was the most unusual thing, because in most companies, some people can get by in politics by hurting you better than they can by going up. That wouldn't happen at a place like Atari, because there was just too much communication. There was no games being played until it got big. So that was fun. Yeah. 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 Oh God. If I knew where it was going, man, I wouldn't be here. I'd be out cashing in on that. That's the best part of it. I mean, we can all have our ideas where it's going to go, but I think, as Alan Kay said, the best way to predict the future is to invent it yourself, right? Yeah. Taking big risks. Yeah. Well, I think it's easier because back when we were doing it, you had an idea to do something, and to make it manifest, you had to put parts together, solder. It took time, months, unless Woz was doing it, months to make a product. Whereas today with software, I hate to say it, but some of the great products, great wealth is being created by less than a year's work on coding. There's nobody gets solder burned or shocked or anything, right? So I think it's almost the reverse. It's so easy, it's so frictionless that you've got a million people doing the same thing. So you better find a niche that is different. I mean, because it's too easy in a way now. And in a way, when there were more constraints, it was easier to be creative. It's bizarre, but we discovered that. We actually did in CoinOp, we had an ongoing project to make the ultimate development machine that could model any kind of game you could come up with. And we spent 10 years doing it. It never worked because we keep changing the technology because the little teams would say, I know how to do that. So you just have to hire great people and stimulate them and let them go and take risk as management. Say, sure, worst that can happen is we flop. And every year we risk the company. On the consumer stuff, we knew that if that thing didn't work, we were out of business. But we were young and reckless.
I think that this is the most amazing time in that way you were just describing, that the tools are with us. And really what makes things succeed or fail as they did then are whether there's uptake.
Yeah.
And we have tremendous new approaches for getting the uptake to happen in social media. And what will change probably is the way that social media drives culture. But anyway, do you have a question?
Okay, so I think I kind of know the answer to this, but I'm thinking about, I mean, I remember some of that era, designing user experience, right? Because it seems like, were you guys thinking, oh, the user will like this or they won't like this or whatever, kind of like as we do now? But I remember at that time, is this going to work? No, it has to go this way to work.
Yeah, I mean, those are the sort of things, but what happened, that's actually an interesting question, because you look back at the first game, Pong, like which way should the paddle go? There were no standards. So which way should the paddles go? I just did it, whatever way I thought. That didn't seem right, that seemed right. You just went ahead and made progress. Because see, if you have to stop and ask, so for example, Nolan, at the end of it, I got it all done, I had the speeds going, the angles, all this neat stuff, the score. Where's the sound? I said, sound? You said I had a 15-chip budget. I'm up to 76 chips. I'm not going to put in these. I want the roar of a crowd of thousands. So I said, I'll do this. So I went back in there and spent a couple hours poking around in the vertical sync generator. There's some good tones. With the one shot, boom, those are the sounds. You want it any different, you do it yourself. Nolan didn't change it. I've seen stories written about how brilliant the sounds were. I think it's hilarious because it was expedient. And because there was no other history. The problem you got today, guys, is there's stuff way before you that is really good. It's really easy to be a brilliant guy when you're the only guy in the field. So that's my secret to success. Be the first guy there, and you have no competition. Yeah.
You talked about the different processors, the 4004
Yeah.
and all that. What do you think about why the 6800 seemed to be like the nicest architecture? And all
The
that?
6502.
Well, and similar to the
This-
68, the Motorola.
Yeah.
But that whole.
Well, the reason at the time between Intel, you know what the problem with Intel was? They had shitty packaging. If you look at the 4004, they were in a 16-pin dip. They didn't have a 24 or 48-pin package. So they had to serialize everything. It was a nightmare. And so Motorola had a better packaging, and they had it in a bigger chip, but they also designed a cleaner system, because, I mean, God bless them, it was the first microprocessor out there, so it came with some very weird pointy-headed things. It just had the cleaner sheet design, and then Chuck Peddle made some mods to that, which doubled the performance, and that was the standard for everybody, well, Apple and Atari. Oh yeah, as long as you didn't mind buying RAM. Back in those days, RAM was very expensive, and so we didn't want to do that.
Maybe one more question. Comment? Well, I think the chance to have people like Al that really lived, you said a dream, but more than a dream, really changed the culture of our country, actually, and done it through technological
Right.
means. It's just so exciting because, it used to be that we always thought that the marketing people ran the world. Actually, if you think about it, Edison, the company Edison was not started by marketing people.
Right.
The telephone company was started by Alexander Graham Bell. Inventors have had their say. And,
Right.
And we technologists here at CMU and people that try to come to this thing, we are actually in a position to take those moments and really create the future. And I think that's what I'm taking away from the talk. Grasp onto the tools and make
Right.
things happen.
Right. Right, because what we did was we just used digital parts to do an analog thing. You know, it was the first time that was ever done. Whoops. My tax guy. All right, thank you very much, guys.